Good morning. So, we start with lecture 1, and generally the outline of this particular lecture, first we will talk about role of materials, followed by something called embodied energy, carbon dioxide emissions, and lowering of cement consumption, etc., etc. So, we will see that later on. So, basically if you look at it, global population is increasing, right, and therefore consumption is also increasing very fast. So, if you look at World Resource Institute, in this is of course when I say 15 years, this is not now because the data is a little bit old, 2010 maybe, right. So, 15 years in the 15 years, say 1995 to 2010, production and weights have been increasing in spite of increasing the efficiency. So, this is happening, and there is something called a living planet report. So, we are consuming around 20% of the resources than Earth can produce. I will explain this actually. This was 20% was much earlier, now it must have gone up far more higher. So, if you see world population growth, this is of course the projected world population growth, right. Now, world population at 2010 was somewhere there, let us say 7,000 million, and increasing in this manner 2,100 it will go somewhere, this is the rate. Obviously, your consumption of all resources increases together with this. Out of this, if you see Asia, rate is very high, and this is what is projected if you continue to grow in the same manner. Africa also very high, Latin America, North America, Europe, Oceania, practically is all stabilized. So, this is the scenario if population is growing in the current in the current rate, right. But if it is controlled somewhat, then it can come down to the level of some level of 2010 or something of that kind, particularly with respect to Asia and Africa. So, these are the continents where population is growing at a very fast rate, right, and therefore, human being for their sustenance needs resources, energy, food, water, everything, right. And Earth of course has got a limit to produce. It cannot produce infinitely. It has got a limit. We will look into that. In fact, if you see the population growth, I have another diagram when I will come to it. It was practically not increasing at any very great rate till possibly about 17th century or so. But with the advent of modern science coming in, the medicine coming in, child birth rate has reduced, I mean child mortality rate has reduced, death at birth and things like that were reduced. So, population started increasing actually exponentially. Now, up in the previous diagram, lower and the upper boundaries and the shaded regions corresponds to low and high variance, lower and upper bounds, as I showed. The extremities, the previous diagram, if you look at it, they are the upper bounds and lower bounds. So, depending upon how you control the population, this is the bounds, lower bounds, this is the upper bound. So, somewhere in between we are likely to be in any case. So, that is what it is. This is the projection by United Nations Department of Economic and Social Affairs. Okay. Ecological footprint is another terminology we use. So, this is one issue. We will come to the like something more related to this population growth and sustainability and things like that. Ecological footprint is a measure, it's a measure of humanity and demand on nature. How much you are demanding on nature. Population is increasing, how much you are demanding on nature. So, the accounting system tracks on the demand side how much land, water, area human population uses to provide all it takes from nature, right. So, that is ecological, that is how we define ecological footprint, all right. So, that is basically it is a measure of humanity's demand on nature, and this accounting system. So, ecological footprint may be even for a process or something of that kind. So, it is basically demand on the nature, and this is essentially an accounting system. You try to calculate out how much, right, on the how much on the demand side, how much land, water and everything put together you use from the nature. So, this therefore includes areas of producing resources, areas of producing resources that is consumed, the space for accommodating the buildings, roads, the ecosystem for absorbing the waste emission such as, well, carbon dioxide is one of them, there are other waste. So, this is so this calculation account for each year's prevailing technology, because technology is changing. So, whatever we have been using, controlling earlier waste, whatever we are possibly making waste, we might reuse some of them with the newer technologies. So, it has to, it is a dynamic thing, this is a dynamic thing and will change with time, with change with time, So, the calculations of each year's prevailing technology. So, currently prevailing technology, according to that this accounting is done. As productivity and technology change from year to year. So, that is what it is. So, that is the idea. Since it changes from year to year, therefore, ecological footprint is calculated on yearly basis, because your technology changes every year. Well, it tracks also supply of nature. For example, how much biologically productive area is available to provide the services, for example, food. Whole of the land cannot provide, is not biologically productive to give us food. Therefore, there is a biocapacity. So, these accounts are able to compare human demand against nature supply of biocapacity. So, ecological footprint is, in this context we define something like this. So, therefore, formal definition will be, it is a measure of how much area of biologically productive land and water an individual or population or activity. So, you can say ecological footprint of cement production, that is an activity. Ecological footprint of India as a country, or maybe Delhi as a state or city. So, one can look into that, right. So, to produce all the resources it consumes and to absorb the waste it generates. So, therefore, also so this is the how much area biologically productive land and water an individual or process or certain area population consumes, and the absorb, the basically measure how much of it the waste generated is absorbed, right. So, using prevailing technology and resource management practices, right, and this is changing quite a bit. If you see, for example, if you go to let me give you an example, like I was just mentioning some time earlier, that possibly in asphalt now you started using crumbed rubber for property enhancement as well as using some waste material. Similarly, in rigid pavement system, you no longer use the ordinary Portland cement alone. In concrete pavement, it is almost a regulation practice to use, so let us say fly ash or similar sort of thing to control heat of hydration and so on. So, you can use some of the waste, right. So, resource management and handling the waste both are accounted, taken care of in this ecological footprint. So, if you see ecological footprint, well, it is a measures how fast consume resources and generate waste. It is a measure high ecological footprint would mean that you are consuming a lot of resources and possibly generating a lot of wastage. So, accordingly that. So, basically there is something called carbon footprint as well, right. And so, basically you can see, so energy is used up in transportation, vehicular transportation, as you can see, also in like this essentially might be coming from the fossil fuel, which is nothing but the deposits of the plants and element remains, which gets converted into, some of them gets converted into fossil fuel. Then food built up that occurs. So, we also do built up food. So, from that it goes, then therefore, timber we use. So, food and seafood, everything. So, this already has got a footprint. So, all this has got a ecological footprint, the transportation that you are using, then all kind of industry or building sector or anything of that kind, the timber you use, the food that you produce, seafood that you produce, all has got a ecological footprint, or a part of it is carbon footprint as well. So, carbon footprint is related to carbon, right. So, ecological footprint is related to all this, all right. So, we can then measure something called a planet equivalent. So, what we have looked so far? We said that world population is growing. Then we said to take care of, to understand how much natural resources human being is using, we can have an accounting system in which we can calculate out the ecological footprint, which will take care of the resources that you are using and waste you are generating, right. And that is what it is. So, all our activities like transportation, building system, food, everything has got is linked to the ecological footprint, right. Now, we define something called planet equivalent. Now, you see the amount of resources the earth can generate is fixed, because two things are fixed. Once its surface area is fixed, and also the energy it receives, it mainly receives the energy from the sun. So, sun gives us energy and it is a periodic thing. Whatever you get every year, most of it is dissipated out also, right, by and large, although the concepts of global warming is coming, which we will look into later on. So, it actually receives and dissipates it out. That means that budget is fixed. Whatever you are receiving is fixed, every year it is fixed, unless you have an artificial sun, hydrogen energy is come by, you create an artificial sun somewhere, and from water you convert the deuterium into helium and all that fusion process till that time, but that would be still very small compared to the energy that you get from the sun. So, every year's energy budget is fixed, area is fixed. Therefore, what planet can give in a year is fixed, right. What planet can give in a year, if we assume that all the energy that you are getting from the sun, you efficiently trap it, but you can't trap everything, it is not possible thermodynamically, because there will be in any process you will have you cannot have 100% efficiencies. So, whatever energy you are getting and the land, both are fixed. So therefore, you can talk in terms of what is called planet equivalent. Now, what is planet equivalent? By measuring the footprint of a population, individual, city, business, etc., nation, or of all humanity, everybody, all humanity, we can assess the pressure on the planet, because economic footprint means you are consuming and generating waste, right. So, whatever you are consuming, that has to come from the mother earth. Now, this consumption will involve energy and obviously the land area as well. So, how much a planet can generate in a year, that you can actually compute out. I mean, it is a large accounting, but one can do that. So, you can measure, you can helps, this of course helps on managing the ecological assets and more wisely taking personal and collective action, support world, support a world where humanity lives within the earth's bound. So, we should be actually consuming that much what earth can produce in a year. Otherwise, we are actually we are kind of withdrawing from the resources already it has generated over the years. For example, the fuel that you get, fossil fuel you get, it has generated for millions of years. So, you are actually withdrawing from there. The reserve that has been created over the years, you are withdrawing from there. And if you go on doing that, you might finish all of them and nothing may be left for the future generations at some point of time. So, that is it. So, earth's bound. So, planet equivalent is related to that. Okay, we will come to that. So, ecological, this is basically based on ecological footprint, and it was conceived in 1990 by Mathis Workengel and William Rees at the University of British Columbia, Canada. The ecological footprint is now worldwide used by scientists, business, government, etc., individual and institution, monitoring ecological resources, use and advance sustainable development. So, this ecological footprint is used in to advance the sustainable development or monitor the sustainable development, right. So, unit is global hectares. Unit is global hectares, right, global hectares. Is measure of area, right, it is a measure of area, because global again for the for the whole world, because trade is global. Individual or country's footprint includes land, sea from all over the world. Ecological footprint is often referred to in short term as footprint. Quite often people just say footprint, and thus should usually people use them capitalized. So, basically its unit is global hectares, right. So, global hectares per person, per capita you can think of, right. So, this is basically a productivity weighted actually area used to report both the biocapacity of the earth and the demand on the biocapacity, right. So, global hectare is normalized to the area weighted average productivity of biologically productive land and water in a given year, in the sense that you see some land can produce lot more agricultural goods compared to another. So, a desert land where you do not have irrigation really, its productivity is different than the one which is on the river basin, where fertile areas and so on, or irrigated areas. So, therefore, there has to be some kind of weightage, right, weightage has to be given. So, 1 meter square is not 1, or 1 kilometer square or 1 hectare is not same. So, it has to be multiplied by that kind of weightage. So, this is the weighted area, right, to look at the biocapacity of the earth. That means agricultural production, or if it is mining, then how much is the mining. So, all extraction or any other kind of thing. So, this is then area weighted average productivity of biologically productive land, then that you can do an like multiplied by the area divided by total area, you will get a normalized one. So, that is what it is done. So, as I was saying, because different land types have different productivity. So, a global hectare of, for example, cropland would occupy a smaller physical area than the much less biologically productive pasture land, whose productivity is less, as more pasture would be needed to provide the same biological capacity as 1 hectare of the cropland. Because world bioproductivity varies slightly from year to year, just digressing a little bit, you see, I think it was beginning of the 20th century, a lot of people were thinking, because population started growing. So, a lot of people started thinking, can the society be stable as it is expanding now? Malthus was one of them, whose idea is that the population increases in geometrical progression, right. So, it is in GP series. Agricultural production was increasing in arithmetic series. Therefore, this is not sustainable, in those days. But later on, technology changed. The productivity of the land increased. The agricultural science came forward, and therefore, this theory never remained valid actually. This prediction or projection was, was not, it did not serve any purpose because things started changing. So, therefore, technology can bring in certain changes, and therefore, this may weights that you are going to use for the same area for agricultural production might change depending upon what is. So, it is basically year to year changes and slightly from year to year, because technological changes do occur. So, followed from this is planet equivalent, which I just mentioned. For every individual or country's ecological footprint, it has got a planet equivalent or the number of earths. Supposing I find out for a particular population the ecological footprint per person, per capita for a given year, multiplied by the world population per person, I found out world population, that will give you the planet equivalent of that particular area, but an overall planet equivalent of the whole world one can find out. So, that means that many number of earths would be required if consumption rate is same as the population that I have considered. So, if you look at total earth's population, you can find out in planet equivalent, because as I said, the total budget area is fixed, energy is fixed, and in the total global hectare that is actually required, that we can find out. So, if everyone lived like an individual or average citizen of a given country, first you calculate out for the whole country per capita, that is for the, then becomes average for that country, and everybody in the world lives for of the similar manner, then for the whole nation you can find out, or the whole world equivalent. So, planet equivalent you can find out. So, it is the ratio of individuals or countries per capita footprint to the per capita biological capacity available of the earth. So, for the whole globe it was 1.78 global hectare in 2008, right. So, that means currently the rate at which the kind of lifestyle they have, if they continue to have that kind of lifestyle, the total global hectare that would be required, one can find out. So, basically you can make it as a kind of ratio footprint per capita to the biological capacity available for the same, right, for the, because earth's capacity is known, and what we require, because we are consuming in terms of food, shelter and things like that, transportation. So, therefore, what is available to us, what we are spending we know, and what is available to us is known. If I take that ratio, that gives me the planet equivalent. That gives me the planet equivalent, right? Ratio that gives me, and planet equivalent means whole Earth taking together, whole Earth taking whole Earth together. So it was for the whole Earth at the current rate of consumption, current style of living, let us say. In 2008, divided by the biocapacity of the Earth, it was 1.7, it was 1.78 the capacity available, and the world average ecological footprint was 2.7 global. So consumption rate was 2.7 global hectare, because we can consumption, so we can actually calculate out how much area, for example, food production, how much area you need to produce that kind of food, and all other resources. So it was 2.7, and 1.78 was the biocapacity of the Earth, because 1.78 was the global hectare was the biocapacity of the Earth, right. Now, both can be measured in ecological footprint, the capacity and your consumption, because consumption means how much fossil fuel you are using, how much food you need, and correspondingly how much equivalent land area you need to produce the same, with weightage. For example, mining will have a different weightage than agricultural and so on. So one can calculate out in this manner, and the ratio would be the 2.7 was what the consumption rate, and available capacity was 1.78. So if you divide 2.7 by 1.78 or whatever it is, you get something like this. So that means on that particular year, by doing a total accounting, we would need 1.48 planet equivalent, or in other words, we need 1.48 Earth, right. So there were 12 billion hectares of biologically productive land and water on this planet in 2008, right, with all weightages multiplied. Dividing the number of people alive on that particular year, 6.7 billion, gives 1.79 hectares per person. So this is an accounting system. Take account of everything, and that's what it was, right. Okay. This assumes that no land is set aside for other species, like other animals and things like that consume the same biological material as humans. So that means you have used everything out, and the other species are simply not there. Since 1970s, humanity has been overshooting, with annual demand of resources exceeding what Earth can generate each year. So till 1970 it was balancing, and this so it now takes Earth 1 year and 6 months, because 1.48. So 1.48 we have seen something of this order. So therefore you need 1 year and 6 months to regenerate what you use in a year, because your land is fixed and you handle all your resources. The energy required to produce, that's also fixed, the budget is fixed. So it's an interaction between land and energy all together, and you need 1.48 Earths. So we maintain this overshoot by liquidating the Earth's resources. So reserve resources actually you are taking out, like fossil fuel, right, which is a reserve resources. Also, let us say mainly this will be the one which would be taking out from the reserve. Also the materials, some of the other materials that you are consuming. For example, if you are producing let us say you are producing motor car, then you are obviously using steel as one of the major material, right. Or if you are using the plastics, that means your again the petroleum products, so crude that you use. So therefore you are actually withdrawing from whatever is available to you, right. So overshoot is therefore overshoot is vastly underestimated. Overshoot is a vastly underestimated threat to human well-being. So therefore we don't, this consciousness is needed. That's what is being said. Health of the planet, and one that is not adequately, currently it was not addressed, but people started becoming conscious. But it's not necessarily 100%, the socio-politically 100% consciousness has come, as we can see gradually. So, that is what it is. This is the planet equivalent versus age, a diagram as you can see. So, one planet is, this is the capacity. All the land, all the water surfaces that you have, if you calculate out its capacity, biocapacity as I was talking about, ecological in terms of ecological footprint, all lands are not useful. So, the weightages has to be given, and all the water, I mean that also may not be useful for your production processes. So, that weightage has to be given also. So, if you do that, then you know that gives you the capacity, also the energy that you get every year from the sun, because both are needed. Now, energy right now we are taking from fossil fuel. Supposing I am able to use efficiently most of the energy from the sun, what is the possibility? So, that would give you the biocapacity of the earth, that is one earth. So, that would be ideal, that you do not extract anything from the mother earth, right, use the sun's energy fully for all your purpose, which is impossible anyway. So, that way biocapacity, but how much you are using now? You can count, because how much fuel you are using, fossil fuel you are using, corresponding energy would be there, how much food you are using, right. So, all this, it showed a trend in this manner in 2010. That means you needed 1.5, that is what I said, that 1.48 ratio of global hectare used up 2.7 divided by biocapacity, and so 1.48, and it would, if it follows the same rate, it would require 3 earths by 2050. So, your planet equivalent will go to 3 times, nearly 3. But if we can control this, then we can even bring it back to 1 planet equivalent. If efficiently we use the system, then we can bring it to 1 planet. So, that is the idea. So, I think we will just break here.